talk's Postgres, the best tool that you're already using. Exactly. So I'm Adam Sanderson. I've been a full stack engineer at Liquid Planner for over 5 years. Just a little heads up for anyone who was at the first keynote. I got off in Kansas, and that's OK. Here's my phone. That's proof. I know a lot of you did too because you were in the upgrading from 2 to 3 for Rails, and I know. And with that in mind, I'm going to try and make sure that everything that I talk about, some of it's going to be more difficult if you're not on the most recent version of Rails. But this is all stuff that you can take home today and start using immediately. I'm on GitHub. It's Adam Sanderson. As soon as this is over and I can find a Wi-Fi connection, I'll put the slides up on there. It's Adam Sanderson /RailsConf 2013. Y'all are pretty smart. You can figure it out. I'm also on Twitter on occasion, and I blog on monkeyandcrow.com. So Liquid Planner, company that I work for, we started in 2007 with Rails 1x, and we've been using Postgres from the beginning. And I'm going to be talking about some of the things that we've learned and some of the techniques that we're investigating and different things that you can do right now with Postgres. All right? Those things are, first, we're going to talk about tagging. Then we're going to talk about hierarchies, how you can model tree structures in Postgres, in SQL. We're going to talk about custom data, so how to handle sparse data in Postgres. And then we're also going to talk about full text search, how you can find comments and other things. So for each topic, first, we're going to cover the SQL before we talk about ActiveRecord. So if you don't want to see SQL, get up and leave right now. And I don't mind. Really? Really? Nobody? All right. We're going to be talking about Postgres 9. We're going to be using the Ruby 1.9 syntax because it's more concise and it fits on slides. And I'm going to be talking about ActiveRecord 4. But everything that I talk about, it's just SQL. And so you can still use this in older versions of Rails. You just need to do a little bit more legwork, OK? And sometimes find gems. Come see me later if you're curious. So a little bit of backstory. You might not know this, but you just finished building a great new social network for hedgehog lovers all around the world. It's Hedged with Me. You could go check it out whenever you get a chance. It's wonderful. It's amazing. Everything's been going great. You've got a few users, like 3, and now they want things. They want new features like tagging. So let's imagine that people want to be able to tag their hedgehogs and then find other hedgehogs with certain tags. How are you going to go about doing that? Well, first, for this example, we're going to have a table of hedgehogs, and each hedgehog is going to have an ID, a name, an age, and then this is the interesting bit here. He's going to have a set of tags that's a text array. Now, promised you ActiveRecord. So in ActiveRecord, it looks more or less like you would expect, except in ActiveRecord 4, they added native support for text arrays, or for arrays in general. You can create an array in Postgres just by using the array true option. It's kind of odd syntax, but it works out. All right? A little heads up. If you're going to do this, use a text array instead of a string array from ActiveRecord. It's because Postgres assumes that your array literals are of type text, not of type varchar, which is what you're going to get with t.string. And if you do that, you're just going to keep getting conflicts all over the place where Postgres is going to complain that the operator that you're looking for doesn't exist because you're trying to do things that overlap between varchars and text arrays. So save yourself some time and just do t.text. So what can we do with these arrays once we've got them? Well, 2 useful operators are the contains operator and the overlaps operator. The contains operator is going to return true if A contains all of B. The overlap operator is going to return true if A overlaps any of B. That means if any of the elements in A or B are shared, you're going to get back true. How are we going to use this to implement tagging? It's pretty straightforward. If we wanted to find all the hedgehogs in our social network who are both spiny or prickly, we just need to look at all the hedgehogs' tags and find out which tags overlap with the array spiny and prickly. So doing this, you might get back something like this. You might see that, say, our hedgehog Marty is spiny, prickly, and cute. Quilby is cuddly, prickly, and hungry. Notice that we don't need to have all of them because we're using the overlap operator. That means that as long as it's got one element in common, you're going to get back a record. Another operation that you want to do when you're doing tagging is you might want to be able to say, I want all of the hedgehogs that are both spiny and prickly instead of spiny or prickly. To do this, we can use that contains operator that I mentioned earlier. So we're going to look for all of the hedgehogs whose tags contain the array spiny and prickly. You'll notice that we get back now is a subset of our previous results. So now we just get back Marty and Thomas, who are both spiny and prickly, because their arrays contained all of the terms that we were looking for. Now, one thing to keep or to note is that while Marty is spiny, prickly, and cute, Thomas is prickly and then spiny. The order doesn't matter. We're only concerned about set operations here. Now, how are you going to use this in ActiveRecord? Well, it's pretty simple. You can just drop this in as a normal condition. So we can just say, get me all the hedgehogs where the tags contain the array, and then ActiveRecord is going to interpolate in spiny and prickly into the question mark. But really, this is ActiveRecord. Aren't we going to do something more amazing? Yeah. We're going to create scopes. This is a useful way for us to teach ActiveRecord a little bit more about our domain and teach it how to do tagging in this case. So if we want to encapsulate the set operators or set operations to find all the hedgehogs that have any tags or all the hedgehogs that have all the tags that we're looking for, we can wrap it up into a scope. So you'll see here we've got the same conditions, and we're doing the same thing. We let somebody pass in, we've parameterized, that is, the scope by the tags that we're looking for, and then ActiveRecord's just going to interpolate them in and use that condition. And you all went to the ActiveRecord talk just earlier, so you know what's going on behind the scenes, right? Yeah. So how do you use this? Well, it's pretty straightforward. Now we can just say, I want to get the I want to do like hedgehog.any tags, spiny, large, and these are just scopes. We've taught ActiveRecord some new tricks. So we can just keep on chaining this and do more interesting queries, like spiny, large, and where the age is greater than 4. Let's find all the old spiny, large hedgehogs. This is really cool because we can now start compositing features, different features with, I have no idea what with. We could start compositing new features. All right, and all these things start working together. Another thing that you might want to do is model hierarchies. I just heard that modeling hierarchies in SQL is hard. I won't argue that it ain't easy, but there are some cool ways of handling this data. Now, apparently, there are thousands of hedgehog leagues, divisions, societies, clubs, you name it, thousands of them, and they follow a strict hierarchy. Our users want to be able to model that. How are we going to do that? Well, if we've got a strict hierarchy, like you've got the North American League, Western Division, underneath that you've got the Cascadia Hog Friends and the California Hedge Society. These are all clubs for people who love hedgehogs. We're going to want to know, how can we support operations like finding the depth of a club? Like, what's the depth of the California Hedge Society? Or what are all the children of the North American League? Or who are the parents of the Cascadia Hog Friends? We're going to do this by using a materialized path in SQL. And we're going to see our old friend, the SQL array again. So for this example, we're going to be modeling clubs. Each club has an ID, a name, and a path. That path is an array of integers. Those integers are the IDs of all of that record's parents. A materialized path is the set of IDs that it takes to descend through your hierarchy to each record. So for example, if you've got, well, here's an example of what this might look like. Here you can see that at the very top, we've got the North American League. it's got a path that's just 1. That's its own ID. We've got the Eastern Division. It's got a path of 1, 2, because it's nested underneath the North American League, whose ID was 1. Underneath that, the New York Quillers have a path 1, 2, 4, because they're under North American League, 1, under the Eastern Division, 2, and then they get their own ID, 4. So with this in mind, how are we going to be able to get the depth? Well, if you looked at the previous slide, you might have been able to guess that the depth of each record is actually just the length of its path. It's the number of parents that this record has. Luckily for us, Postgres has a function, array length, that takes in an array and it uses a dimension, and it's going to return, you guessed it, it's going to return the length of the array. The dimension for our uses is always going to be 1 because we use one-dimensional arrays in this case. I don't know what an n-dimensional hedgehog club tree looks like, so we can skip that for now. So when would you want to actually use this? Well, let's say that you wanted to just display the top 2 tiers of your hedgehog clubs. To do this, we already know that the depth is just the length of the path. So you can just use the array length function on path to get the depth. So we're going to select out the name and the path and the depth of that club, and then we're going to filter these by array length. We're going to filter it so that it's just the clubs that have a depth less than or equal to 2. Get back something that looks a bit like this. You're going to get back the North American League, Eastern Western Division, and the South American League. These are only the ones that have a path that's no longer than 2. When would you actually use this? You might use this to, say, provide a table of contents for deeply nested data, or just to show people like the top levels, give them a summary, or if you're modeling a tree, just show only things expanded out to a certain level. So I also said that we would want to be able to find the children of a club. To find the children of a record with a materialized path, you just need to look for all of the records who have that record's ID in their materialized path. So if we know that the California Hedge Society's ID is 7, we can just look for all of the paths, all of the records whose path overlaps the array 7. As you can see, this means that you're going to get back the California Hedge Society itself, real hogs of the OC, and the hipster hogs, because each of these have California Hedge Society's ID in their path. Now, if you get one takeaway from this, it's that apparently it's illegal to own hedgehogs in California. This is a very important fact that I learned while researching, and it was on Wikipedia, so it's true. What about the converse? What if you want to find the parents of a record? Well, we already said that a materialized path is just the list of the IDs of the parents of that record. So if we already know the path, California Hedge Society, its path is 137, we can take that and then compare that with the ID of each record. Here we're going to wrap up that ID, if you notice array ID in the where clause. We're going to wrap that up as an array so that we can use the overlaps operator. So which records overlap with California Hedge Society's path? North American League, Western Division, and California Hedge Society itself, because each of their paths or each of their IDs are contained in that path. So this is a really convenient way to be able to model a tree or hierarchy data in SQL. So now I didn't explicitly say this, but in ActiveRecord 4, arrays are just exposed to you as an array in Ruby. So on the ActiveRecord side, if you want to do something like find out the depth of a record, you can just check its path length. Well, that was easy. What about querying? What if we want to find the parents or the children in ActiveRecord? Well, since we're looking at relations, we're going to ask for all the parents or the children in relation to a certain record. You're going to want to do this as an instance method. So here we're going to use the children and the parents methods, and they're using the same logic as I showed previously. And in each case, they're going to pass in their own ID or their own path, respectively. what this lets you do is you've now taught ActiveRecord something about how to query hierarchies. So you can use it just like any other ActiveRecord method. You can chain it. So you can now do things like say, I want all the parents, but I only want 5 of them. Or, we've already taught it about tagging. So you could say, I want all of the children of this club, but I only want the ones where the hedgehog, that contain a hedgehog that's silly. It's what I do all the time in my spare time. The point here is that these features all can work together. Every time we implement something new this way, we've taught Postgres or we've taught ActiveRecord some new tricks. Now, what about custom data or sparse data? What if your users want to be able to record arbitrary data about their hedgehogs, of course? For instance, maybe they want to be able to track what their hedgehog's shoe size is, or his favorite food, or his eye color. Well, what if I don't want to do that? We don't need to have a column for everything in our database. Postgres has got a nifty thing called hstore. hstore provides a column type that's a hash, essentially. And it's a useful alternative to ActiveRecord's serialize, because with an hstore, you can actually query it. Yeah, you can actually query it. And that's great. Now, a little bit to get set up. hstore doesn't come installed by default with Postgres. It is, however, shipped in Postgres's contrib modules. So all that you need to do is make sure that you actually create the extension for Postgres. You just need to drop a migration in. It's going to execute some arbitrary SQL. In this case, the arbitrary SQL is to create the extension hstore. Now, a little heads up. Although hstore is supported by ActiveRecord 4, the default schema format doesn't support extensions. In fact, the default schema format for ActiveRecord only is going to support things that use the ActiveRecord helpers. The problem here is that if you take this and you try and use it in your tests, those aren't going to get materialized in your test database. And you're going to run your tests, everything's going to explode. So to work around this, I think it makes sense to switch your schema format to SQL. Then, anytime that you modify your schema, it's going to get captured that way. So save yourself a huge amount of trouble. And if you're going to use anything fancy like hstore, make sure that you use the SQL schema format. So for this example, we're going to now have a custom column. It's just going to be an hstore. It's just a column type. Just so you can see it in ActiveRecord. Here it is again. hstore, normal column type in ActiveRecord 4. So you can do like t.hstore. Pass it its name and some options. Specifically, those options are important. Take a look at the default and the null false. This is going to save you a huge amount of hassle. Make sure that you specify a default empty hstore. That's what you get with an empty string. And make sure that you don't allow null hstores. If you can think of a use for a null hstore, let me know. And I'm going to tell you that you're going to save yourself a huge amount of time by always making sure that you've got one. Otherwise, your new records are going to have null values there. So if you try and set keys on it, your app's going to explode. Just saving you guys a little hassle. So that hstore format, you guys already saw what an empty hstore looks like. It looks like an empty string. What about a non-empty hstore? It looks more or less like a Ruby 1.8 hash with extra quotes thrown in. So just to explain what you're looking at, here we're going to set the custom field for a hedgehog. We're going to set his favorite food to lemons and his weight to 21 pounds. Notice that you've got quoted key value pairs, and then they're separated by commas. Did anyone go to any of the security talks? Does this look like a SQL injection attack waiting to happen? Be seriously careful with this. Don't go and concatenate up strings yourself. If you're on Ruby 1.4, ActiveRecord's going to take care of it for you. And they write more tests around that than I probably would, so I think you're in safe hands. What are the operators? I told you before that you're going to be able to query an hstore. So here are the two common operators that I think are most useful to know. The first is defined. It tells you, quite obviously, if the record A or if the field A contains the value or the key B. The second one is the accessor. It gets B from A. This is essentially the same thing as calling A square brackets B in Ruby. It's just a hash accessor. So how can we use that? Well, if we want to use that, we could say, find all the favorite foods of the hedgehogs in our social network. So you see here, we can select out the name, and we can pluck out the favorite food from the custom field and present it as if it were a normal column. Then we can filter that down to say, only return the records where we actually have a favorite food defined for that field custom. As you can see, you're going to get back a table with names and foods, even though food wasn't a column in your database anywhere. It's just something that we stashed away in the HStore. So for instance, Horace likes lemons, and Quilby likes pasta, and Thomas grubs on grubs. This is a really useful way to model sparse data. All right, back to ActiveRecord. You guys might have guessed that we would do this, but a nice way to be able to wrap up this functionality is to wrap it up in a scope. So if we want to teach ActiveRecord about using HStores and querying against them, we can define a scope for hasKey and a scope for hasValue. How would we use this? It's trivial. Once you've got that scope set up and we've taught it about what those operators do, we can now just say, hey, give me all the hedgehogs that have a custom color. Or, hey, give me all the hedgehogs that have a custom color that's brown. Or, hey, give me all the silly brown hedgehogs. Again, we're able to teach ActiveRecord new tricks that are able to combine together and all work in concert. If it doesn't look like there's a whole lot up here for the ActiveRecord, that's great, isn't it? Saves you guys a lot of time, and it's not that hard to understand. Now, what about updating HStores? Well, as of ActiveRecord 4, HStores are just hashes, or represented as hashes on the Ruby side. So if you do hedgehog.custom, you can set its favorite color, say to ochre, a nice color if I may say so, or you can just replace you can just replace its existing hash. Say, replace its favorite food with peanuts and its shoe size, because that's important. Little heads up, though. HStores are always stored as strings. So if I set my hedgehog's custom weight to 3, I save it, I reload it, I'm going to get back an integer, right? No, wrong. You're going to get back a string. It's not the end of the world. You just need to know that you're going to get back strings and deal with it. Full text search. Your users want to be able to search for stuff. In this case, your users want to be able to search within their comments. They want to be able to type text in and find out like who said what. We're going to model this as, for this example, as a bunch of comments. Each comment's got an ID. To make things interesting, they're all about hedgehogs, just because. So they've got a hedgehog ID, and then each comment has a body. Now, there are two important data types in Postgres' full text search. The first is a TS vector. This represents the text that has been pre-processed for Postgres to search. The second is a TS query. This represents the search query, or more precisely, a search term, or combination of terms. Now, for symmetry, there are two useful functions that you're going to use to get these. 2TS vector and 2TS query. They give you TS vectors and queries. They both take in a search configuration. A search configuration is something like English, or Polish, or hacker speak, or pirate, you name it. And then the text that you want to convert into either a vector to be searched or the query to be doing the search on the vector. What's important is that these create normalized vectors and normalized queries. What do I mean about normalized? Well, here are a few of the things that Postgres does when it normalizes your vectors and your queries. First, Postgres removes common stop words. So for instance, If we do 2ts vector on a boy and his hedgehog went to Portland, you're going to get back boy, hedgehog, Portland went. It strips out things like a, and, his. And conveniently, this is also the same algorithm that my boss uses to write me emails. So, but we try not to pick on him too much. Another thing that Postgres is going to be doing is still normalization. Another thing that it does is it stems the words that you're searching on. So for instance, stemming basically chops off common word endings. For instance, hedgehogs becomes hedgehog. Enjoying becomes enjoy. Piping becomes pipe. And you're going to see why this is really important in like 2 slides, so curb your enthusiasm. Operators. Postgres has just got tons of operators, and some of them are great. So the operator that you're going to want to know about for search, the most important one, is the search operator on vectors. That's this @. That means that we're going to search the vector v for the query q. The other 2 operators that are important for full text search are the and the or. These let you combine search terms. So this will let you search the vector v for a and b, and it'll let you search the vector v for a or b. All right, let's use it. So if you want to find all the comments about enjoying something, we're going to prepare the body of our content, or our comment, by calling 2ts vector on it with the English search configuration. And then we're going to query that for the query term enjoying. What are we going to get back? A bunch of comments. What's important here is that you're going to see that you get a bunch of different matches on enjoy. For instance, does he enjoy beets? I really enjoy oranges. I am enjoying these photos of your hedgehog's beady little eyes. Notice that we search for enjoying, but we also match on enjoy and enjoys. This is because of the stemming that goes on in the normalization phase of Postgres' full-text search. This gives your users a little bit more flexibility to search for random things and hopefully get the right result back. Another useful feature of the query, or of the query terms, is that you can do wildcard matches in Postgres. For instance, if I search for cat : that's going to search for anything that starts with cat. For instance, cat, catapult, cataclysmic, but that's only going to match things that end or start with cat. So it's not going to match octocat, sorry GitHub. It's not going to match scatter or prognosticate, which is a great word. So to use this, if you wanted to find all the comments that contain oil and something that starts with quill, we're going to prepare a vector on the body of our comment using the English search configuration, and then we're going to search that for the term oil and for the term quill with a wildcard. And we're going to combine those 2 queries. What do we get back? What brand of oil do you use? Have you tried Quill Swill? It goes down smooth and it's delicious, folks. A little heads up, because this gets weird. TS query only supports wildcards at the end of a term. This is because of the way that Postgres has implemented its indexing. So while quill star or quill : will match quill swill, star : swill will not. Instead, it's going to explode. It's going to throw an error, which brings me to even more heads up. Never pass user input directly to TS query. It's got its own mini search syntax, and all of the following are going to fail because each of these are using characters that TS query reserves and has special meanings for. So either you need to sanitize your queries, or you need to find a gem that does this for you. Now, how can we use this in ActiveRecord? I'm sorry, it's obvious. We're going to wrap this up in a scope. And it's going to look just like the SQL that I showed you. So we're going to prepare a comments body with the English search configuration. Then we're going to search it for something that I sanitized on a different slide because the definition's way too long to show here. If you want to see it, come and talk to me. you're going to need to write that sanitized query or find a gem that does it for you. So for instance, you might want to find all the comments about krill oil again, but now you want to limit it to just 5 results. Hey, we taught Postgres how to do full text search. So now I can do search all krill star oil and limit it to 5. Keen observer back there, you think that I dropped the colon? No, because I'm parsing this myself, I get to define my own syntax now. So you can just do krill star in this case. Because we've taught Postgres how to do this as a scope, you can chain it along like all the other examples. You can combine this with other things that we've taught Postgres about your domain model. Now, you don't need a full text search index to do searches in Postgres, but it's going to make it a lot faster. And you always want things to be faster, don't you? So what we can do is we can create an index on the function call, 2ts vector English, on the call which is the call that we were doing to prepare our search content. And then we can use a gin index. This is a special type of index that Postgres uses for multi-value columns like text arrays or TS vectors. Now a little heads up. Since we're indexing a function call, you've got to use this the same way in all of your code. If you don't, Postgres isn't going to know isn't going to be able to use its index. So if you index against 2ts vector English and then you use Polish, it's not going to hit your index. You don't always need to use English. You just need to be consistent. So in summary, with Postgres, you can use arrays to model tagging and hierarchy. You can use HStore to model custom data, sparse data. And you can use Postgres to do full text search. And now, you can enjoy the happy hour. Hey, any questions?